Hello and welcome to Algebra 2, Chapter 6.7, Using the Fundamental Theorem of Algebra. So, what is the Fundamental Theorem of Algebra? It says if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one root in the set of complex numbers. Okay, so what this says that if you have a degree of 1, 2, 3, 4, etc. there, if you have a degree that's a positive number, then you have at least one root in the set of complex numbers. Now, if we remember about a complex number, remember your standard form of a complex number is a plus bi, okay? But remember though, if a is 0, then you would just have an imaginary part, and that's a complex number. But at the same time, b can be 0, and you would just have a real part. So just because it says a complex number, it doesn't mean it has to have an imaginary part. It could just have a real part. So what this is saying is that you're going to have at least one root. Alright, so some things to remember when you are solving polynomials is that you're looking for as many answers as your degree. So you're going to have as many roots as your degree. So if your degree is n, you're going to have n roots. Okay? And sometimes though you might have repeated solutions. And so if you have a repeated solution, let's say 3 happens twice, you do have to count that twice to get all the way up to as many zeros as you're looking for. And you can factor or find possible rational zeros in order to solve. So remember in the last section we talked about possible rational zeros was your p over q, where p was your factors of your constant and q is your factors of your leading coefficient. And that will help you solve. And then also remember graphing is a good way to help you zone in on what those zeros are going to be. So, state the number of solutions and tell what they are. So, how many solutions is this going to have? Well, I would say we're looking for at most 2 solutions. Remember, you can have repeaters. And so, looking at this does look like it's going to factor. So, let's see here. If we factor this into, I think it's x minus 7, because that would be a positive 49 and negative 14. So in this case, x only equals 7, so we have one solution. It's actually a repeater solution. Okay, so there are 2, but they're both 7. So really we have one solution, and that solution is 7. So remember back to chapter 5 and all the ways you can solve a quadratic. Since this is a quadratic, those all still apply. Okay, so state the number of solutions and tell what they are. So we're looking for at most 4 solutions because we have a degree 4. And so, one thing we can do is we could graph this, which we might do in a second. If we did our possible rationals, you're looking at plus or minus 1, 2, 3, 4, 6, 8, 12 and 24, just all of those, all over 1. Okay, so that's nice. So the next step might be to let's graph it. So let me pull in a graph. Okay, so here's our graph. And by the way, this is equal to 0 if we're looking for our zeros. And so it really looks like negative 4 is 1, which would fit what we put up there. Maybe a positive 4. Oh, positive 3, I can't count. 1, 2, 3. Okay, so, but it could be really close to it and not be exactly. So you really need to do your synthetic division to make sure that that is what that number is. So we're going to go ahead and do our synthetic division. We're going to do 1, 3, negative 8, negative 22, negative 24, and we're going to divide this by, let's do positive 3 first. So we're going to drop, multiply, add, multiply, add, multiply, add, multiply, add. Perfect, that's what we're looking for. Now if you want to, you can go straight off of this one and let's try -4. So drop, multiply, add, multiply, add, multiply, add. Perfect. All right, so there's 2 of our 4. That leaves us, if this was an x to the 4th, this one would have been an x cubed, so this is a 1x squared plus 2x plus 2. Okay, that does not factor, because you can't do 2 and 1 and get 2 in the middle. So let's do quadratic formula. So x equals -b plus or minus the square root of b squared minus 4, that's a 4, times a times c, all over 2 times a. So -2 plus or minus the square root of 4 minus 8. So it looks like they're going to be imaginary, but that's okay. -4i, because it doesn't say the real solutions, it just says what are all the solutions. So this is -2 plus or minus, don't ask me why I put an I under the square root, you don't do that. How about 2i divided by 2, which is going to be -1 plus or minus I. So there's the last 2. We also had 3 and -4. So there are the 4 solutions, so we do need to note that as well. There are 4 solutions, and that is what they are. Okay, so again, this is just a different set of directions, but find all the zeros here. So we're doing the same thing. You know, you might start with your list of P over Q. You know, so plus or minus 1, 3, 5, and 15 all over 1. You might graph it. You know, if without graphing it, it's just a guess. So if you did 1, 1, -1, 15, I'm going to try 3. You know, so let's drop, multiply, add, multiply, add, multiply. All right, so +3 didn't work. But you know, at the same time, you still need to try -3, because there's nothing that says that -3 might not work. So if you try -3, drop, multiply, add, multiply, add, multiply, add, there you go. So -3 works. Leaves us with a quadratic, and when you get down to a quadratic, sometimes it's just easier to go ahead and solve using quadratic formula, because yeah, this doesn't factor, so it's not going to have any more rational zeros. So you're looking at -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So 2 plus or minus the square root of 4 minus 20. So 2 plus or minus the square root of -16. That's a 16. So 2 plus or minus 4i over 2. Don't know what happened there. Let's try that again. 2 plus or minus 4i all over 2, which is going to be 1 plus or minus 2i. So there's 2 solutions, and our other one was -3 for all 3 zeros there. All right, just a note, on that previous example we just did, it does factor, and of course, you know, we pulled out that -3, so it factors into x plus 3, and then we had our x squared minus 2x plus 5. If x minus k is raised to an odd power, the graph will cross the example. So because x plus 3, there's one of those, the graph crossed at -3 there. But if x minus k is raised to an even power, the graph will be tangent to the x-axis, which means it's a repeat solution. So for example, if you have something that factors into x plus 3, x plus 3, x minus 2, what's going to happen is, because you can write this as x plus 3 squared, so it's raised to an even power, and there's a few ways that could happen, but it's going to come up and it's going to just touch at that point. And so it's a repeat answer because it actually kind of happens twice. And then positive 2 happens once, which means that it's going to actually then cross through positive 2, and you might end up with something that looks like that. Okay? The other thing, and this is going to be really important here on some of our last examples, is that all complex solutions come in complex conjugate pairs. So if a plus bi is a 0, then a minus bi has to also be a 0. Okay? So if 5 minus 2i is a 0, 5 plus 2i is a 0. They have to come in pairs. So that's only for your complex solutions there. Okay, so one more time, find all the zeros. Okay, so we're looking for a total of 4, and if I do P over Q, we're looking at our options of 1, 2, 3, and 6, and it's going to be over 1. So if we do our synthetic division, though, we have to remember to put in that 0 for x cubed, and a 0 for x, I was about to skip that one. Let's try that again. So x to the 4th, x cubed, x squared, x, and then our constant. And I'm going to try 1. All right, so we drop the 1, multiply, add, multiply, add, multiply, add, multiply, add. Perfect. So 1 works. And then if you want to continue from where you are there, you can. So 1 works. I'm going to try -1. So if we drop, multiply, add, multiply, add, multiply, add. Oh, perfect. Look at that. All right, so 1 and -1 both work, which leaves us with x squared plus 6, because there's no x in there, equals 0. Okay, so really I would use square root property here. Go ahead and subtract 6 to the other side, square root both sides, and then x equals plus or minus I square root of 6, which makes our 4 answers be 1, -1, and plus or minus I square root of 6. So there's all 4 solutions there. All right, so now to write a polynomial of least degree, okay, that has real coefficients and a leading coefficient of 1 with the following zeros. We're going to have 1 as a 0, -2 plus I as a 0, and -2 minus I as a 0. Remember, those complex ones always come in conjugate pairs. Okay, so if these are our zeros, then what are our factors? So if x equals 1, x minus 1 equals 0, makes that be a factor. So I have a factor of x minus 1. And so what you do is you are subtracting it to the other side. So then we also have x minus -2 plus I, and you're going to have x minus -2 minus I. And I would do a little bit of rearranging here. X minus 1 times x plus 2 minus I times x plus 2 plus I. Okay, and so what we're going to do is this equals 0. We're going to multiply all of these together. It is helpful if you multiply your complex ones first. So multiplying the x first, we're going to make x squared plus 2x plus ix, we'll do it like that. And then multiplying the 2, we're going to get plus 2x plus 4 plus 2i. And then multiplying the negative I, we're going to get negative ix minus 2i minus I squared. Okay, and some of this should cancel. Ix and a negative Ix, and a positive 2I and a negative 2I. And remember, then I squared equals negative 1, so a minus I squared turns into a plus 1. So we're looking at x squared plus 4x plus 5. I think that takes care of everything, and we're going to times that by x minus 1. Okay, so we're distributing again. I'm going to distribute the x and get x cubed plus 4x squared plus 5x, and then distribute the negative 1, which would be a negative x squared minus 4x minus 5, which leaves us, let's try that one again, leaves us with x cubed plus 3x squared plus x minus 5 equals 0. There is our polynomial with least degree, because we have degree 3 because we had 3 zeros, with a leading coefficient of 1. So there it is. And we're going to try that one more time. So same thing, least degree, leading coefficient of 1 that has zeros of 5, 2i, and negative 2i. Okay, and again, it's giving you the conjugate pairs. If it just gave us 2i, you'd have to add the negative 2i. So watch that on your assignment. So x minus 5 is 1, x minus 2i is 1, and x minus a negative 2i is our other one. So those are our factors. We're going to go ahead and simplify just a little bit, x minus 2i and then x plus 2i. And remember, it is easier to multiply the complex ones together first. So if we FOIL, we get x squared plus 2ix minus 2ix minus 4i squared. Okay, your ix's cancel. I squared is negative 1, which turns that last term into a positive 4. So you're going to get x squared plus 4. Take that times x minus 5. We'll figure out what my pen is doing wrong here. I'm not sure. Alright, foiling one more time, we're going to have x cubed plus 4x minus 5x squared minus 20. And with a little rearranging to put it into descending order, there is your polynomial with least degree. And really, we probably should say f of x equals those. Least degree, leading coefficient of 1, and all real coefficients. All right, let me know if you have any questions. Have a great day. We'll see you in class.